to us about ultimate copy elision.
Yeah. Hello, everyone. I'd like to present you some idea that I'm presenting to the C++ standardization committee, and this idea will make all your programs faster and smaller and cooler. So, here's the motivation. And we may see here some code, and we also see that I'm really optimistic because I have more than 50 slides. Now, what do we have here? We've got some structure. It has default constructor, move constructor, destructor, some member function in it. And we've got three static functions. Produce functions creates an A variable, does something with it, returns it. Function update accepts a B variable, does something with it, and returns a B variable. And shrink does exactly the same thing. Finally, we've got a function caller, and it calls produce, update, shrink, and stores some result. Now, what do you think your compiler will do with that code? It will do a lot of ugly things. If we remove some helper instructions here, we'll see the following. We've constructed an A variable, done something with it. After that, a compiler done a great job. It done a copy elision, so we don't have a B variable actually anymore. Instead of B, we keep working with A variable as if it was a B variable. We call do something on the A variable, and after that some crap happens. Because the compiler provided a move constructor here. He calls a move constructor and uses C. After that, a D is constructed from C, and a bunch of destructors is called. The thing here is that we don't use B and D variables anymore after the move construction. So instead of creating a new variables, we can reuse the old ones. And that's basically the whole idea. If we've got a variable, we move construct or copy construct from that variable and don't use that variable anymore, well, then we don't need a new variable. We can reuse the old one. That's mostly the idea. And what I'm proposing to the C++ committee is to allow this optimization. Who's scared at this point? Yes. Don't be so scared. First of all, I've got some good news for you. If we allow this optimization, then your code becomes 2 times shorter and 2 times faster and uses less stack. And yes, it's scary, but take a look here. Compiler already does this thing. Well, it does it already, and your code's still working. Compiler already does it, but let's allow the compiler to do this in more places. And in that case, we can get better compile times. Because now compilers have big functions, they're forced to optimize them. Instead of that, they could remove the copy elision and optimize the smaller functions. Also, well, compilers do optimization, but not always perfectly. So if they inline all the move constructors, destructors, and try to optimize that code, they quite often fail to succeed and fail to elide all the unnecessary copies, all the unnecessary operations with memory. So if we allow those optimizations, we'll get better performance, less stack usage, and smaller binaries. And finally, if you're teaching someone a C++, well, that's a problem. At some point, you have to tell people about std_move because, well, it makes your programs faster. However, if we allow those optimizations, and they'll be really good implemented, the implementation will be really good, then we don't have to use std_move so often. So if we teach people, we can just say, well, sometimes you may use std_move, but we can tell that stuff to people at really late stages, when they're already afraid of C++. Now, that's it. Thank you for listening. If you have any questions, find me. I'm ready to talk about this topic anytime. Thanks.